Hi, I'm Levi, and 3 or 4 months ago I started one of my most ambitious projects yet. I wanted to design and build a robust desktop CNC mill. This is a project I've been interested in for a long time. In that last semester I took an advanced metalworking class, which gave me access to an entire metals lab, so we're talking like $100,000 or more worth of really cool metalworking equipment. And in that class, the final project was just something of your choice. Your goal was to just make a thing that involved all the machining processes. There were example projects that were like building a hammer or some other simple tool like that. But instead, I wanted to take it all the way and use this as an opportunity to build something super cool. I also knew that I wouldn't have access to all these really cool tools forever. I knew that I would be moving away over the summer for an internship, and then I would be moving away yet again after that to go to college. So I figured I could use these tools to build myself a mini version of one of those tools, the CNC mill, that I could then take on with me. So I wouldn't need the entire metals lab. I could kind of take a little bit of it with me wherever I go. So that's the idea. I wanted a CNC mill that could fit on my desktop, but that was still as robust as I could possibly manage. And I've owned a small CNC router that's in a similar family as the thing I want to make, and I've had that for a long time. But I want to build something that can do a whole lot more. Namely, I want to make something that can cut steel. My current little router could never do anything like that, but if I could cut some ferrous metals, that would be super impressive and would actually open up the possibilities of things I could make going forward. So the plan is to make a CNC mill, and the goal is to cut steel. Oh yeah, and one more thing. The time I have between starting this project and when I'm moving out is 2 weeks. So I need to design and build an entire complex system in 2 weeks. But before we do get into this big, exciting project, I need to thank this video's sponsor, which is Atlas VPN.
Atlas VPN is making the internet more accessible and secure for everyone. Atlas VPN currently has a massive deal on their 3-year plan, costing just $1.39 per month with a 30-day money-back guarantee. This deal won't last forever, so make sure to take advantage of it via the link in the description. You're on YouTube, so you probably know what a VPN is, but if you don't, it allows you to redirect your internet traffic through encrypted servers around the world, masking your data and your IP address. This allows for cool stuff like access to geographically locked content, censorship avoidance, and increased security on public Wi-Fi. Atlas VPN goes above and beyond the norm with the Data Breach Monitor. After inputting your email, the Data Breach Monitor searches the internet to see if any of your personal information has been leaked on any data breaches or data dumps. By notifying you when such an event takes place, this tool puts the power to preemptively and proactively protect your valuable personal information. The internet can be seriously ruthless, even for people who really know their way around. For me, the biggest benefit of using Atlas VPN is its ability to counter many of the tricks hackers use. You can even use their tracker blocker tool to prevent data brokers from stepping on your privacy and to reduce things like malware ads. Again, they have a great deal going on. It's just $1.39 per month with a 30-day money-back guarantee. This deal is limited time, so take advantage of it via the link in the description. I started this project with the CAD model, as is the norm. I loosely based this design off of the Nomad 883, which is a commercially available desktop CNC machine, which does a lot of the stuff that I want mine to be able to do. The key difference though is that I just beefed up everything. To constrain my linear actuation, I have 20mm stainless steel rods. For my gantry assembly, I've designed aluminum plates that are 25mm thick in certain places, and the whole thing is inside of a 3/16 steel box. This project had a lot to tackle, so I decided to start with the steel box, which is the main frame. The main reason I started with this is just because I knew I could do a lot of it at home. Remember, I only have 2 weeks to do this, so I have to be as efficient with my time as possible. I need to be working on this every waking moment. If I start with something that I can work on at home, then I can make progress at home and in the metals lab, and I can be as efficient with my time as possible. The Metals Lab has this big, beautiful CNC plasma cutter that I use to cut out all the panels for my steel box. The machine is bright orange with this funky green sludge, so I got some really cool shots of it in action. When I first designed this box in CAD, I wasn't super happy with it just because it looked really thin and kind of flimsy. But once I started to handle this steel and feel what the actual pieces were like, I was kind of thinking I probably should have dialed it back a bit because this thing is massive. It's so heavy. I had to pick up and move all these steel plates into my car so that I could bring them home to work on it over the weekend, and that was a monumental task. That was no small feat. I got the pieces home, and then I spent the entire weekend working on that box. The first thing I had to do was drill out the holes made by the plasma cutter. This was especially painful because those holes are hardened by the plasma. So I tried to temper the steel back by heating it up with a blowtorch, and then I drilled it out, which worked pretty well. It also warped the piece a little bit, but I got that figured out. Then I ground off all the dross, and I cleaned up every single edge on every piece. Plasma cutters tend to cut at an angle, and I needed that to be straight for everything to go together correctly. So I spent a lot of time with the grinder and then a lot more time with the wire wheel, cleaning off all the rust and preparing the plates. And there was even a casualty. I caught my favorite jacket, which you see me wearing the whole time, in the wire wheel and chopped a hole right in the middle of it. So sad. Next up was welding the frame together. I almost certainly didn't need to, but I really wanted this box to be really sturdy, so I opted to weld the entire length of every external seam. And this thing is kind of like a cube with some bits chopped off, so because of that, you can't just deform one piece. If you want to deform one piece, you have to deform all of them, really. And this is actually my first real welding project, so as far as first projects go, I think this one's pretty cool. That being the case, the welding was pretty nerve-wracking for me, but it was also really fun, and in the end, I'm pretty happy with how my welds turned out. But I'm not gonna give you any super close shots of them because, I don't want people screaming at me. I was a lot less worried about the quality of the welds, and I was more worried about the plates warping due to the heat. The accuracy of the system is not really dependent on how straight the plates are, but if they get really out of whack, it could affect the accuracy. Fortunately though, I was able to take it slow, and I didn't get any warping really at all. So now I guess I can add welding to my resume, so that's cool. I then spent an ungodly amount of time grinding it smooth and making it look pretty. I gave it a good degreasing, and then I was ready for paint. Then I gave it a couple coats of primer and a few coats of glossy white paint, and all of a sudden it looks like a real thing. Like seriously, I don't know how I made this because it looks way more professional than most things that I touch. And I do realize that white paint is going to get dirty really quick, but it looks really nice now, and that's all that matters to me for the moment. So at this point, the big box thing is done, and all the important bits are not done. The primary mechanism is based around two big chunks of aluminum. The chunks are a lot bigger than any stock I had available, so I had to kind of make my own stock. I did a lost foam casting to make two big chunks of aluminum. Those could then be machined square, and then their fancy features could be added after the fact. Machining these blocks square was wonderful. I'm very new to machining, and I've always thought that it looked pretty fun, but in reality, it's so much more fun actually doing it. Going from this rough black chunk of metal to something perfectly smooth and shiny is just an absolute blast. At this point, my stock was all prepared, and I was ready to use what is the king of the metals lab, the Haas 3-axis CNC mill. But before we get to that, we need to talk about this man right here. This is Mr. Schubert, and he is single-handedly responsible for making this project possible. Not only has he taught me everything I know about machining and metalworking, not only did he spend countless hours in here helping me out on this specific thing, but he just straight up gave me all the stock I needed to do this entire project, which would have otherwise been by far the most expensive part. All the aluminum, all the steel I needed, he just gave it to me. Without his skills and expertise and without his generosity, this project would have been entirely impossible. Not to mention that Mr. Schubert is just a great guy all around to talk to pass these many hours in the machine shop with. It was a pleasure to be able to spend all this time with him, and I am so thankful for all of his help along the way. Now that I've got the necessary thanks out of the way, we can get to the Haas. Like I said, this is a 3-axis CNC mill. It's the real deal. It can do all the materials you want to do. This thing is beautiful and terrifying simultaneously because it is so very powerful. It has an automatic tool changer, so what that means is once you get everything set up, which can take a little while, but once you do get everything set up, it can effectively output pretty much a finished product. My toolpath did leave a tab on the bottom that I had to mill off manually, but other than that, it was a finished product. And our Haas had all the best tools in the machine shop, so all the finishes were beautiful and pristine, like mirror finish kind of stuff on this aluminum. Working with this machine was so fun, and just the fact that I can press go and then it just does everything is mind-blowing. A few of the pieces needed to be cut from this 1/4 inch thick aluminum plate. The Woods Lab has this big CNC router. I suppose it's intended to be used for wood, but it can also do aluminum, so we used it for these pieces. The main thing you're seeing here is the fixture plate. It's where all the stock material gets bolted down to. It also has over 100 holes, each of which needed to be tapped. I'm not going to show you that, I just want you to understand my pain. And with those pieces finished, along with a little bit of off-camera magic, all the pieces I needed for this machine were finalized, and I was ready to move into assembly. Assembly for this thing was just an absolute treat. I've spent every spare moment from the last 2 weeks straight building this machine, so to be able to just finally get everything together and then just run with assembly, it was just such a blissful experience. Things were fitting together. It ended up taking a lot longer than I expected it to, but, you know, it gave me the opportunity to really savor the moment. This whole thing is so beefy and heavy. It was just exhilarating to put the whole thing together. And now you're watching me have a silent existential crisis as I realize that the very final piece does not fit. I guess this project was just going too well, so I decided to completely faceplant right at the finish line. And now, in the next day, I'll be driving 1,000 miles away, leaving my project unfinished. But fear not, because our story has a hero, and our hero's name is Jesse. Jesse of Husky Machining. So I let him know the problem I was having, and he was happy to take it off my hands. Jesse sent me a beautiful, shiny, smooth replacement to all my specifications that did actually fit. I'm very grateful for his help here. He does great work. Check out his channel. I'll leave a link for it in the description. I will say that this mistake was not entirely my fault. When I designed the CAD models, I designed everything based off of the manufacturer's specifications, or as best as I could find, and that wasn't an issue except for this one piece. The dimensions that the manufacturer gave were extremely off, so yeah, they didn't work at all. Admittedly, I really should have known not to trust those numbers, and I should have measured it myself, but, you know, I was in a time crunch, so what are you gonna do?
See if this works. I should be good to try and make this thing move.
I should also mention that I've had a CNC router before this, and I'm just cannibalizing all the electronics from there and sticking it on this. So I do expect it to work, and I'm not worried about destroying the other thing because this is replacing that.
5 millimeters in the positive x-axis. Wrong direction. Y and X need to be flipped. I'm gonna do that. Okay, so all the axes move in the correct direction. I think the only next thing is to try out some test cuts. Let's see what this thing can actually do. I have attached this little vise here. I have a 2-flute 1/4 inch end mill here. I believe this is tungsten carbide, so it should be pretty resilient. I'm not gonna be running any G-code. I'm just gonna be jogging the controller back and forth to take some cuts. As far as feeds and speeds go, I'm gonna be guessing, so we'll see how that goes. This first piece is oak, so it's a relatively hard wood. It is hardwood. Everything should be good to go, so I guess I will just try and cut it. And here goes nothing. Yeah, I cut it. It definitely cut it.
In conclusion, it cuts wood without any difficulty.
I got some bar stock aluminum in there, hardware store aluminum, so an unknown alloy. Bringing down the feed rate. I'm trying to just touch it. Here we go. It's super ugly.
I eventually realized that I didn't have the right collet size for that 1/4 inch end mill. I switched out to an 1/8 inch bit, which I do have the correct bit for. It's also 2-flute tungsten carbide.
See if this works. Yeah, that was a lot better. That's so much better. It's a smooth finish. Oh, and I mean, they're not like good chips, but they're a whole lot more of an actual chip than what I usually do. It's not just aluminum dust. Well, I like that. I like that a lot. Okay, in conclusion, it can cut aluminum. Those first tests, those don't count. Now we have the holy grail of desktop CNC mill materials. What is this, mild steel? I can cut anything I would ever want to cut on this machine. This whole thing's pretty darn robust, so I think it could probably handle it. Okay, I'm just gonna try and touch the surface. And I think the name of the game for steel is to keep a low RPM. Here goes something. There's a possibility that the piece is like not totally flat in there and it'll like hit halfway through or something. So I really need to sneak up on this, because if I accidentally take too deep of a cut, I am breaking some. Whoa. Well, it's a good thing we did that. That looks like a cut to me. Yeah, I think we're cutting steel. It's definitely cutting through it, and it's not like jagged edges or anything either. It's straight lines. I'm calling that a finished project. So I successfully designed and built a desktop CNC mill, and it cut steel. I am ecstatic with how this project turned out. This thing is built like a tank. The final weight is 90 pounds. It makes me so happy. Just looking at it, the shapes, the form, all the exposed rails, it was a blast. I'm decently confident that you could throw it off a 2-story building and it wouldn't do anything more than scratch the paint. And though it couldn't take very deep cuts into steel, as was very much expected, it certainly was cutting steel. And if you give the machine enough time, it could certainly cut some very usable parts out of mild steel. That allows you to do cool stuff like making custom transformer cores or custom motors. Being able to machine ferrous steels does really open up the amount of stuff you can do, especially the amount of electromechanical stuff you can do significantly. The only problem though is something that I really should have been aware of in hindsight, but I was kind of wearing rose-tinted glasses, so I wasn't paying attention. And it's the fact that bringing a 90-pound big desktop CNC across the country to go to college or for an internship is not even remotely practical. I kind of told myself in the beginning that I could take this with me wherever I go, so I could have that machining capabilities no matter where I was in the country. But you know, it's still really big. It wouldn't fit in a dorm room at all. And honestly, I'm fine with that. Initially, I just was looking for reasons to build it because I knew I really wanted to build it. And then in the back of my mind, I was kind of aware that it wouldn't be the most practical thing given what I'm going to be doing in the future. But whatever, I wanted to do it. I did it. It works great. I'm happy. So yeah, this project was exhilarating. It was so fun. I got to work with such cool machinery, got help from some really cool people, mentors. I did a lot of machining practices that I've never done before. There was so much learning to make this. This project's pretty different from some other videos I've done, and I like that. I don't want to be confined into just building, actuators. I want to build like everything pretty much, and this furthers that dream. So if you like this kind of big ambitious project, subscribe to the channel. I'm going to make all the CAD files available via my Patreon. So if you want to support me on Patreon, you can support me, my work, and you can get the files to potentially make this machine yourself. You can join my Discord server to engage in conversations about cool projects like this, see what other people are working on, and contribute to projects even. You can also follow me on Instagram for some other pictures of stuff I'm working on. Links for all these things will be in the description. Thank you again to Atlas VPN for sponsoring this video and making these like large projects possible. Thank you to Mr. Schubert for giving me the material, his time, all of this. This project would have been totally impossible without him. And an additional thanks to Jesse at Husky Machining, coming in at the last moment to give me that final part to finish this cool project. I hope you enjoyed it. I know I certainly did. But that's all I have for you today. Bye.